questions. I'm now recording. So we have 3 days left, and we're going to work on chapter 7. It's a new data type in the worlds of words. It's called a data type. It's a new data type called an array. Now we had something called a string. So I'm going to start with a string. And when we would declare a string like str, and then we would say str gets a value of hi mom. Well, what happened here? Well, what happens was str gets not a value, but what is stored there?
Memory address.
Yeah, a memory address. Something like AX120. I don't know what it is. Never really delved in to find out what it means and so forth. But it has this hexadecimal representation, and it stores a memory address. Now, over here in memory, at this address, AX1203 or whatever it is, I start to see, first of all, H is stored, I is stored, space is stored, M is stored, and these are all stored side by side. Okay, and there's a little bit more going on to this that I don't want to get into, but it stores an address, and it comes over and it says, okay, I'm going to store all of these individual characters, even though this is a string. Think of it as individual characters side by side. I'm going to store them in memory locations that are of size 2 bytes. Being that they're characters, they're going to store them in size of 2 bytes. So remember when I said str.char at 0, what did it give me? It gave me the character H, didn't it? Right? If I said char at 3, now this guy gave me the H. If I said char at 3, what would it give me? Well, it would go, this one was the 0 one, this is the first, this is the second, and this is the third. It would be this capital M. It would give me the character capital M. Well, this is exactly what you started doing with your code listings and what we're going to do with chapter 7 arrays. We're going to create a data type. That's an array. The array is an address. We're going to go over to the address, and we're going to store side by side memory items that are the same data type. Like these are character, 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 character. A lot of the examples you did would have been an int. So we're moving over int by int so it knows what to look for. So if I said I want to store an array of integers, whatever my array name is, so if I gave the array name numbers when I declared it, numbers is going to be a memory address that's going to take me over to the starting location, and I'm going to be looking for a way to store whatever size I declare this array, that many numbers side by side. And if you think about a number, an integer, how many bytes is an integer?
4.
4. So here's 4 bytes, 4 bytes, 4 bytes, 4 bytes. So if I said, oh, I'd like to have an array, and we take a look at these square brackets called subscripts. If I said I'd like an array of size 4, it goes, oh, these are numbers. I need to go find 16 bytes so that I can put these 4 ints side by side. I need 16 bytes to store the 4 ints side by side. And using what we know about a string and a char at, this is like 0 location. So this is numbers sub 0. This is numbers sub 1, sub 2, and sub 3. So I'm able to store the exact same data type side by side by side by side. Okay. If I want to get to a certain location, numbers sub 0 is here. Numbers sub 1 says, hey, go to the numbers address and move over 1. But in computer words, it's not really moving over 1. How much memory is it moving over? 4 bytes, right? So if I said numbers sum 3, it's going to this memory address and move over 3 times 4 or 12 bytes so that I can start reading the 4 bytes in that location. Big overview. Let's see what we got. An array can hold multiple values of all the same data type simultaneously. If I want to declare an array, I'm going to create an object once again. I'm going to create an object. And the object is an integer array. And I'm even giving it a size. When I give it a size of 5, I know I'm going to use up subscripts 0, 1, 2, 3, and 4. So this guy right here is numbers sub 4. Number says, hey, go to this address, move over 4 times 4 bytes, 4, 8, 12, 16, so that I can get to that location. Okay. Numbers holds the starting memory. That's what I mentioned a couple of times. Holds the starting memory of the address. It moves over when I want number sub 2, 2 times 4 bytes. Moves over to there. Now, if I just use the word numbers, it's an address. We don't need to really get into that. You'll get into that in 161, dealing with addresses. Okay. But what numbers sub 1 is an actual number. It's the integer that's stored in there, like 23. So this is now an actual int value. I can move it over to here. Here's another int value. Whatever was in 0, I assigned a number sub 3. So these are all individual integer values. They're just stored side by side by side, and I can get to them with a single name like numbers. Instead of creating 1, 2, 3, 4, 5 different variables, I only need to create one variable name, and I can hold them all. What if cost is an integer, and I want to assign it to number sub 5? I don't have a number sub 5. I will get an error message that says exception out of bounds. So when you see this error, you'll know what it is. You're trying to use a subscript that's not 0, 1, 2, 3, or 4, as in this case, with an array of sub 5. And loops, 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 loops. What we learned in chapter 4 is going to pay off big time here. What do I have? I have an array, and I want to go through and print out all of the values in my array. I want to print out number sub 0, number sub 1, number sub 2, all the way up through. How do I do it? I use a loop. And then I use my loop control variable, in this case counter, as the value in my subscript. I saw 1 or 2 heads nodding. That's good, I think. Okay, so what if I had a loop and I wanted to put values in, like 5 or 6? That's easy. I can just do it right from the keyboard. But what if I want to take an array and put values in, and it starts to get to be a lot, and I already know what they are ahead of time? Well, if I already know what they are ahead of time, I can hard code this right in my program. This is called implicit initialization. This says, I'd like to declare an array of integers. I don't have to declare the size, because when I use set notation and put values in, it will do the size for me. So 31 will be in days sub 0, days sub 1, 2, 3, 4, 5, 6, 7, 8. This is days sub 8. gets the value of 30. How big is this array? This is an array of size 9. It goes from 0 to 8. So if I want to work with the array days, I can only use the subscripts 0 through 8. And again, I'm hard coding them right in my program in the beginning so that I don't have to enter 31, 28, 31, 30, 31, 30, 31, 30, right? Days of the first 9 months. I ran out of paper on the end, so that's why there's only 9 instead of 12. It happens. Okay. The length of the array. This is kind of nice. What if I forget how big my array is? Up here, I did it implicitly. And if I said, what's the length of, what is days dot length? It would give me 9. What if another way, what if I have a whole bunch of data and I can't hard code it in, but I store it in a data file? And there's 1,000 pieces of data. And I don't, I got to read them all in somehow. But once they're all in and stored, if I want to know how big it is, I can use this numbers dot length. That'll tell me how big my array is. Unlike other methods, you notice numbers dot length doesn't have parentheses because I wrote it in there. It doesn't have parentheses. Something a little bit different. And as always, we know at the end of our for statement, just like if statements, we don't end it with a semicolon. Probably half of you have had that problem this semester. My program's perfect, but I'm in an infinite loop. Yes, you are. You're in an infinite loop because you had a semicolon there. Nothing's getting done, or you're stuck in a loop. Okay. Not a lot more. Array 1, this is my assignment operator. I'm not doing equals. Array 2, can I do that statement? Well, the answer is yes. Is it good? No. Because remember what I said array 1 is. It's the address. So this guy right here, if I said array 1 gets the value of array 2, that means down here at the bottom, you see what I have going on. Array 1 now gets that same memory address as what array 2 had. So they would go to the same spot. Array 1 sub 3 would it be the same value as array 2 sub 3. If I change it in one, the other one ends up being changed as well. So if I want to copy arrays, I need to do what we sometimes refer to as deep copying. I get down in there and get into the nitty gritty and the dirty, and I copy one element at a time. I go through each one. Okay, so you had some code listings. Let's see what you got going on here. We talked about arrays, and hopefully you didn't just jump to the code listings. You did some of the reading beforehand. But if I take a look at this code listing, I come in, I declare an array of size 3. Int, empty square brackets, hours equals new int. And our author loves to have this named constant, is what it's called. But we could have just put a 3 in there if we wanted to. What's going on? Down here in line 21, it looks like I'm going to fill an array with values by hand from the keyboard. I read them in, I store them in our sub loop control variable, 0 up to 3, and I print out the hours you have entered were, and then it displays them. Here's a loop that now goes through everything again for 0 to indexes less than employees. I could have also done less than hours dot length if I wanted to here, because that would have been the size of the array. So you typed in 7.2. Were there any questions on 7.2? 7.4. Here we go again. This is what I just mentioned in my notes. Implicit initialization. I throw it right in there in the beginning. It's in there and it's done. And we all know how to count the days of the month, right? We do the knuckle test. We count across our knuckles. January, February, March, April, May, June, July, August, September, October, November, December. Whatever one was a knuckle is 31. So January, February, March, May, July, August, October, December. Yep. See, you learn something new every day. All right. You typed in 7.5. Okay. Let's see. What do I have going on? I have my declaration of my array. Doing it over and over and over and over. Int. Square brackets. Hours equals new int and a size. I come down here. I'm reading everything in from the keyboard. And then I'm displaying it. I'm using a loop. And again, there's my array value. Here's my array value. Pay array. So that's 7.6. You typed in 7.6. Bunch of good stuff in here, right? Uh-oh. What do we have going here? Line 13. I don't know how big the array is yet. So what I'm going to do is hold off. Then I'm going to come in and I'm going to ask how many test scores there are. And now I'm going to declare the size of my array. So I did like half of that array declaration, waiting until I knew how many there were to make it an official one. This is kind of going to be handy for assignment 7.1, folks. Just saying. And then we go through and we can fill the array and do our work from there. All right, you typed in 7.6. You have all kind of stuff going on. We yeah. Is that as far as we got? 7.1 and 7.2? I believe so. All right, so let's see what we have going on here. I want you to now do a program. I want you to read in 10 numbers from the keyboard and store them in the array. Once they're stored in the array, then I want you to have a loop that goes through and finds the largest, a loop to go through and find the smallest, and a loop to go through and find the average. Now you're saying, well, why can't we do all that in one loop? Because eventually we're going to take a look at the little blocks of code we're making here, and we're going to turn them into methods. So if you make them blocks now, it's going to pay off later. So make each one of these loops an individual loop. Then I want you to display everything. Hey, here's your 10 numbers. The largest is blah, blah, blah. The smallest is blah, blah, blah. And the average of the numbers is blah, blah, blah. So first thing I might be considering is, the ever popular test data. And give me some test data for this. How about this? 10, 20, and 30. But you're going to say what? Well, that's not 10 numbers. Well, if everything's up and running, can I switch to the 10 numbers later? Yes, you can. So if I just want to run it for 3 right now, I know what the highest is, I know what the lowest is, and I know what the average is going to be. How about this set of test data? 1, 1, and 2. What's the highest?
2.
2. What's the lowest?
1.
What's the average?
If these are integers, it'd be just 1, right?
But we always do average with decimal places. So thinking of test data, if you said, here are 3 numbers, 1, 1, and 2, and I said, okay, the average is 1, you'd have a fit. You all be like, no, it's not, it's 1.33. You'd want to tell me what it is. So I want you to format the average to 3 decimal places. If it was money, 2 decimal places.